Okay, so we're going to do potential energy now. We can basically get rid of all this stuff. We still have a mass, still the ground here. We'll have a mass, and so we have a weight. We have the force of weight down here. That's equal to m times g, obviously. And then what we're going to do is we're going to lift this up to a certain height. And then to do that, we're going to need an axis, and we'll call this the y-axis. Okay, and then this is going to be the height. So it's going to be y equals the height there. And then we'll actually call this, actually for now, we'll call that y as the height there. And that's y equals 0. Because we'll define that as the ground. And, okay, so we saw that this force was along this the whole time that we rose up to that height. So that means that the work is the force times the distance. So W is going to equal this force times the distance, where here is m times g, and then the distance is going to be h minus 0. And so we can say this is y minus y0. And so since that's y0 is going to equal 0 and y is going to equal h, then we can say this is mgh. And so that indeed equals the potential energy. So that's basically how we get potential energy, pretty straightforward. Because the acceleration is the force is constant, we just take it times the distance, and that distance, assuming that we define the ground as 0 coordinate, then the height that we raise it to is just going to be, or the potential energy is going to be the force of gravity times the height, which is great. Okay, so now I'm going to move on to potential and kinetic energy. So if we know we have a certain amount of potential energy here. We say that the initial velocity is 0, and say we just drop this from a certain height, and it's going to drop to the ground like that, and then it's going to have a velocity when it gets down there. So initial height, and then it falls because of the force of gravity. It accelerates. So we know the acceleration is going to be g, 9.8, and then so this is also going to have a velocity. And so lots of times what we want to know is what is the velocity or what is the kinetic energy when it falls. Kinetic energy is easy once we know that. You know, kinetic energy is 1/2 mv squared, and that's an equation we're going to always want to remember. So I'm going to go ahead and write that down. Okay, so we already have it here, and I'm going to write it again. Potential energy, I'll write this in blue. Potential energy is equal to mgh. And then kinetic energy is equal to one half v times squared. So I'm going to All right, well, that's a little smushed, but whatever. Okay, so yeah, initial velocity is 0, final velocity is v, initial height is h, the final height is going to be 0. So we can write this as all the potential is going to have all potential energy, kinetic energy is equal to 0 at time t, or time t equals 0. And then at time, the final time, then it's going to equal, it's going to be all kinetic energy. So we can write this as mgh is equal to 1/2 mv squared. And I should just write out a few of these. But that's what it's going to be. So that's our equation. And since we got mass on both sides here, we can cross that out. And so then it becomes v squared is equal to 2gh. And then we just square root that. And you use this equation a lot in your homework, 2gh. And we square root that. All right, and that's basically our equation for the velocity. It is our equation for the velocity. For this situation, we'll see a lot where it starts from rest and then falls to the ground and has 0, falls to the ground, which is y equals 0, so then it has 0 potential energy. So all potential energy goes to kinetic energy. And it can also happen the other way around. Whereas, say, we shoot it from initial velocity, and then we ask what height we'll go to. And that's similar to what we did when we were doing kinematics, but now we just do in terms of the energy, which can be really easy. So if we wanted to figure out the final thing here with conservation of energy and potential kinetic energy due to gravity is where will this be if we wanted to find any time here, say in the middle. And so that'd be pretty easy. Do this in blue. One times V there. Initial there, so that's our initial kinetic energy. Okay, so yeah, actually I'll do this as a time-dependent equation. Because amount of energy is constant, but the amount that's kinetic and potential energy will change. So yeah, actually, no, I'm going to keep it as initial and final. Okay, so then that's our equation for potential and kinetic energy. So here's initial and here's final, and that just equals energy, which is equal to a constant. And that's basically a conservation of energy. For now, there are some different aspects to this. There's non-conservational conservative forces like friction that we can add into this. Also like potential energy from a spring. And I'll address these down the road and answer any questions that you have about that. But I'll wrap this up for energy for now. And thanks for listening to this lecture.